Welcome everyone. So yeah, today I'm talking about on-chain NFTs. So kind of why I think they're cool, what you can do with them, and how to make them kind of quickly. Before I get into that, so I'm going to, so who am I? So my name is Reed. I've been a full-time crypto developer for a little over 3 years now, and I'm a full stack web developer for almost 10 years. So since joining Alephium or finding Alephium in around November, I've developed Alpha.pro, which is like a crypto indexer and DeFi portfolio tracker for all your kind of DeFi positions. It's got a Discord bot integration, and so you can check your balances and token prices from Discord. And I built this for the first Alephium hackathon. Moving on, my Shades of DeFi was my first NFT collection, and the first NFT collection, first SVG collection on Alephium that I'm aware of. So basically, the way I made this was I generated the images off-chain and hosted them on IPFS, and then minted them through Dead Rare. And they're kind of a funny EVM developer-focused collection, which was a bit of an inside joke for myself, building it on Alephium when it's got a bit of a funny Ethereum inside joke inside of it. But next I built What the Duck, which was similar in architecture to Shades of DeFi. So it was an SVG collection. I hand drew all the ducks, all the layers, and then compiled everything myself, compiled it all off chain, hosted it on IPFS again. After Mint, I've been developing a multiplayer game where you can play as your duck and kind of explore this little duck world. And I'm continuing to work on that and build that. The Alephium vending machine was also built during the hackathon while I was working on Elf.pro. So when we kept having these open office calls and everyone was talking about how there was no snacks at the open office calls from the hackathon because it was just Zoom meetings, right? So so I made this Alephium vending machine, which it's like a website and it's a vending machine. You can go select what snack you want to buy, and if there's enough inventory, you can buy it. So there's about 20 different foods and 50 inventory of each starting out. And finally, more recently, Minting Time is my most recent collection, and it's on-chain generated clocks. And so all the NFT is fully generated on-chain in real time as you go to view it. And so it kind of enables some pretty cool kind of opportunities and directions you can build with. So my talk today, basically, I'll start off with like what are NFTs, and I'm sure most of you or all of you already know, but I'll just kind of go through that a little bit and the important aspects related to moving it on chain, and then I'll actually go into what parts of the contracts you'll have to change to move the NFTs to be fully on chain. And then I'll do a case study, which was kind of diverges from more general advice on what you should do to specific problems I had when developing Minting Time and how I chose to solve them. But there's many other ways you could solve these sorts of issues. And then, just closing up there, I'll talk about like how to make them a little bit more dynamic and other ideas in the future for people to build or myself to build. So starting out, what are NFTs? So they're like from a very like high level, there's something that's ownable, right? So you can own it, it sits in your wallet. They're transferable, so you can send it between people if it's not locked, obviously. They're transparent, and what I mean by that is you can like look at the blockchain and you can see all the data about the NFT. You can see who owns it, you can see the image, you can see the traits, all that sort of stuff. They have rarities, so each NFT like is unique in that only one of them has been minted, and that is kind of its purpose. But even like within a collection, there's rarities within the collection, right? So you can have like a certain number with like blue hair or what have you, right? So, and then finally, they're indivisible. So like unlike, Alpha or Ethereum or anything like that, you have one. You can't have half of an NFT. You can like tokenize ownership or fractionalize ownership but even if you do that, the NFT itself can't be fractionalized. So kind of getting a little bit more technical. So like, what are NFTs? So on the Alephium blockchain, they basically consist of two main components. So the first one is the standard UTXO. And that was kind of discussed earlier with MG Pai's talk. He went into UTXO in detail and it was great. But basically, this is just a standard token. It's the same as any other token you have in your wallet, Alph or Wrap Bitcoin or anything really. And yeah, this is a token that's in your wallet. And the other component is the smart contract. And so every time you mint a NFT, there's also a subcontract or a smart contract that gets deployed alongside it. And this newly deployed smart contract is what keeps track of all the metadata of the NFT. So this is different from chains like Ethereum, where there's one central contract that tracks everything. On Alephium, it's a contract per NFT, which is pretty interesting and kind of changes how you think about developing for them. So yeah, as I said, the contract holds all the metadata, so it holds all the attributes, all the rarity traits. And in some cases, like Gold Castle, for example, has dragons that you can mint, eggs, and they can evolve into different like evolutionary dragons. And so only the owner is allowed to do these actions and interact with the NFT. So there's a bit of like a permissions model that you can build on top of there. And it provides read-only access to the metadata URI, which is kind of the most interesting part that I'll be talking about here today. So diving into this metadata, so like, what exactly is it? Basically, the most common function anyone's going to interact with regarding token or NFTs is get token URI. And generally it returns just a URL like HTTPS. This one points to IPFS. This is one from my What the Duck collection. In most cases, they are just simply a static JSON file that's been uploaded somewhere and made available. They're usually hosted on IPFS or Airwave, at least on Alephium. Those are the two kind of more popular options, but they could also be just an S3 bucket on Amazon. And there's pros and cons to all of these, right? So like Airwave is immutable and it's permanent. So once you upload it, the images and metadata, it's there forever. You don't have to worry about it. IPFS is immutable, so it can't change on you, but it relies on someone pinning the content. And generally this is a creator that does this. But if they ever unpinned the content and no one else had it pinned, then the metadata and the image would be inaccessible. So, you could get rug pulled there, or honest mistake, or plenty of options of that going bad, right? And Web 2 infrastructure, you could just have a web server or an S3 bucket, and it's very centralized, but it gives you some like kind of more dynamic ways and more control over what you can do with it, but it's also very trusting and very centralized method of doing this. So this is kind of the more common ways that it's done today. So if we take a look at the actual metadata example, so at the top is the URL, and so you can see it starts with IPFS, and so that's this is the IPFS gateway I'm using, and then it's got this long random-looking string, and that's the contract, or that's the data hash for IPFS. So this is how they work in their immutability into their system. And at the end there's /36 because this is token ID 36. So it's zero based, so this is the 37th duck. So if we look at the JSON itself, it's got a name and a description. Oftentimes people don't include the description and it's only a name, but they pretty much always have a name. And then it has an image tag, which also points to an IPFS location in this case. And then it's got the attributes. And so if you look at all the attributes in all the minted collections, that you could calculate rarities for all these different traits. This would have many more attributes, but I deleted a bunch just so it would fit on the screen nicely. So you could count how many ducks have blue hair and calculate the rarity from that. So a quick recap, basically an NFT is a UTXO token that lives in your wallet. It's got one smart contract per token. and the smart contract points to or returns a metadata URL, and the JSON and the image itself are usually hosted elsewhere. And they are usually static and don't change. Gold Castle, as I mentioned earlier, is a good example because it has static JSON, as I've been talking about, but the token URI itself actually changes when like the dragons evolve. So through using that mechanism, it's the same as this. It's static JSON, but next time after the evolution, the image will change and the metadata and traits will change. So it's a cool kind of solution to this problem. So moving on from this, let's talk about moving all this data on chain and kind of go through, see what that looks like. So from the spec, the get token URI, it simply returns a URI or a URL. And most commonly, like all of the time so far, on Alephium at least, this is a HTTPS URL that points to one of these places. And you have to use a network request to fetch it and get the JSON back. But if we look at, to quote Mozilla Developer Docs, or MDN, data URLs allow developers to embed content directly into the URL instead of linking to an external source. So what that means is we actually have a way that we can save the JSON into the URL itself without having to make that extra network request. And so like, what exactly does this look like? Basically, if we just focus on the data on top and the URL on the bottom, what we need to do is prefix it starts with data : and then we prefix it with the MIME type. And then pretty much we can just inline the JSON directly after that. And now when this gets fetched, like same as you would normally do, instead of returning the data from over the network, your browser or your Node.js program or whatever you're building will actually just return this JSON directly. And the cool thing about this is all now on chain, right? So it can take advantage of like fields or state from the contract itself. But we still kind of have problems with this. The image in particular is still hosted on IPFS. So if we were to use contract state to like change the traits and generate different traits, it can be really challenging to keep the traits and the image in sync, right? So we need to find some way to move the actual image itself on chain. And storing data on chain can be kind of tricky and kind of expensive. So one way to do this, though, is using SVGs. So most NFTs and most images on the internet are like JPEG, PNG, WebP. I think those are the most common formats, and they're all like binary in nature. So they are very efficient across the network and across like good to save on disk, but they're difficult to work with. You usually need specialized tools like Photoshop or something to edit the images. SVGs are, on the other hand, are text-based. So it's a markup language, so it's very similar to writing HTML. The syntax is the same, some of the tags and stuff are a little bit different. But you can actually style it with CSS. You can use CSS animations to animate them. You can actually use JavaScript and embed JavaScript within the image itself. But in a lot of contexts, that's disabled for security reasons, so probably don't want to rely on the JavaScript to do anything too crazy. But being text-based makes it a lot easier to work with, right? Because you can store like chunks of text, concatenate them together, and like build your images out that way. So what we're going to do now is we're going to move the image on chain. So basically, same as before with the JSON. We're going to have the data : and then the MIME type, which is text SVG, and then the raw SVG image itself. So here it is. This is the full JSON metadata and the image itself on chain, just stored, hard-coded as one super long string. So this works, but it also still has some problems, right? Like the most obvious one is it's being entirely hard-coded, which means they're all going to look the exact same. And so this kind of, it might be okay for some use cases, but usually you're going to want some variation between all the NFTs. So yeah, let's look at how we're going to, yeah.
So are the SVGs, are they all like vector based?
Yeah, yeah, exactly.
So actually also the quality and sharpness of the image will also be much higher because you
totally, yeah.
it's scalable.
Exactly. So they're always, yeah, always super crisp, no matter any size. There are limitations, like just due to contract length or contract size and gas length or gas usage, as to the complexity of the SVGs. So oftentimes, I don't know what the limit is, but you can't get like really crazy SVGs all on chain just due to those restrictions. But there's still a lot of potential, yeah, for sure. So kind of from here, I want to talk about how I chose to get them dynamic with my minting time collection. And so how I chose to get all the clocks to have different traits and unique and individual traits, and then generate them all. So before I do that, I'll talk a little bit about what minting time is. So it's a collection of 377 clocks. It's the first fully on-chain SVG collection on Alephium. And it's every time you view the image, it fetches that metadata URI that I discussed earlier, and it will generate the clock in real time as you fetch it. And it's a simple SVG clock, and then I'm using CSS keyframes to like animate the seconds hands and like that. So basically the way it works is I fetch the block time. When you request a metadata URI, I fetch the block time, and then I have the time zone offset, and I add those together, and then I can know like the time for that specific clock, and I can use that as a CSS variable when generating the SVG. So one problem I had is, how am I going to get all these 377 clocks to have individual time zones entirely on chain? So I kind of did the silly thing, and I just deployed 15 smart contracts just full of arrays of bytefacts of all my data. And so something like the Merkle tree, which was discussed earlier, would be much more efficient, but this way I could use it fully on chain. And then from there, I have a random contract that allows me to pick any one of the time zones that I have deployed. Then mark it as used, so it won't get picked again. And then when the mint happens itself, I fetch this random time zone, add that as fields into the NFT when I deploy the smart contract, the subcontract. And then after that, I'll be able, once the mint's done, I'll be able to deploy or destroy the 15 smart contracts here and kind of get my deposit back from that. But so basically, yeah, so I embed the time zone data and the time offset into the smart contract when it's deployed. And then when get token URI is called, I can calculate the time using the current block time, which I'm calling from the Alephium node that it's connected to. And then I just add the offset in seconds, and I can calculate the seconds, minutes, and hours from that. Then I generate the metadata JSON, so I can generate all the traits, including like the last time that the image was actually processed. So you can tell if there's like caching issues, things like that. But also you can generate different rarities, because like there's not 377 different time zones in the world. Many times there are different locations that have the same time zone. So it's kind of a little bit of a rarity system built in. And then I generate the SVG clock, and I use the seconds, minutes, and hours as CSS variables. And then I just animate the whole clock using CSS keyframes after it's been loaded. And then, of course, I just return everything as one big long string in the data URL. And overall, it seems to be working pretty good. So going beyond this, like what else can we do? How can we push this? I think there's a lot of kind of cool directions. So like some ideas I've had is you can, like I'm only reading the block time, but you can interact with other smart contracts and pull data from them. So you'd be able to make like an NFT that visualizes like INLP reserves, or a step further from that would be getting the reserves and calculating a token price. So you could have an NFT that always displays the current token price as reported by the DEX. You can, really reflect any sort of contract state. So like staking balances oftentimes have that data available. So you'd have NFTs that display your current staking balance. You can also do like more kind of gamified or interactive things. So you could do like NFTs that decay or fade or turn transparent if you don't transfer them for a certain amount of time or don't interact with them for a while. Or you could do like digital bonsai tree that kind of continues to grow over time. One thing I'm working on is next kind of series of What the Duck, and I'm working on dynamic traits. So working on like a trait marketplace where you can kind of build your own NFT and customize it. And yeah, I think there's just a lot of fun, a lot of potential for this kind of tech. So that's that's all I got for you today. So thank you. So, any questions?
So a really nice presentation, really cool to see what you're building.
Thank you.
Really enjoyed that. So I'm just wondering, have you also built NFTs on other platforms, on other ecosystems?
I've built them and I've played with them, but I haven't like launched any projects.
Okay, but could you make some comparison about kind of how the experience is to develop an NFT on Alephium versus maybe another chain, and maybe you could say something about what can Alephium do, or like so you showed some of these new things that you're developing, like with SVG, but also some of the other traits that you're importing. Is this something specific to Alephium, or?
So these techniques basically I've borrowed from like my knowledge from like EVM networks.
Yeah.
So all this stuff is like at a high level is composable, and you can use it on EVM networks, and people do. Like the Uniswap V3 LP reserves, they've got like an NFT for their LPs, and it's the same sort of thing. Yeah. So the Alephium more side of it is more kind of changing your mindset, for me anyways, because on EVM you have the single collection contract, then you have to build like these interfaces to kind of handle all accounts, whereas this is like a contract per NFT, so you kind of, I don't know, it's just a different kind of mindset for me when I'm developing it anyway. Yeah.
Did you get anywhere close to the limit, the size limit for this contract, or could the SVG potentially be much bigger?
So one thing I did with the minting clocks is I actually also wrote like a base 64 encoder. And so like the reason I did that was for compatibility. There's just displaying the raw SVG and building the SVG string. Like it can be hard to build valid JSON sometimes, like to get all like the double quotes in the right place, especially when you're embedding SVG within a JSON file, because the attributes and yeah, it's just hard to build a valid string. So what I did was I base 64 encoded my SVG. And so where I'm going with this is I ran into very hard limits on gas usage from my base 64 encoder. And I got the SVG, I can base 64 up to, I think, like 4,000 characters before I start running into gas problems. But as far as the SVG itself, you can return, I don't know what the limit is if you're just returning raw SVG. No. I think the contract itself can store 32 kilobytes, and yeah, you could probably pull data from several sources if needed.
Yeah, it's just need to test it out.
Yeah.
It's not a technical question, but I've from the shades of DeFi,
Yeah.
to the snack machine, to the minting time now.
Yeah.
I personally like how you find new things.
Thank you.
But I also wanted to ask you, like the duck game.
Yeah.
Is it still being developed?
Yeah. So I'm working on a new collection for the duck game so that we can get more players in and more people playing it. So the current game that I have now, it's a little bit held together with duct tape. Like I'm not a game developer. I'm just kind of learning how this stuff goes together. But I learned a lot developing what I have so far. So I'm working on a new collection so that more people can play, but I'm also rebuilding like the entire game from scratch using modern game development tools. My current one, I built all myself just to kind of explore new technologies. But yeah, so I'm rebuilding it. I'm using Godot. So I've built a bit of a bridge between the Godot interface, if anyone's a game developer here. I've got a bridge between the Godot interface and the Alephium like blockchain, so I can call my NFT, or I'll call whatever I need to from the actual game engine now. And yeah, I'm just working on making that more scalable. And then this actually came out as part of a research, kind of a bit of a research project for the next version of Dux, because I want them to be customizable, and I'm going to have a trait marketplace and working on like an inventory system so you can like collect items in game. So yeah.
That's awesome. And will you build like a time vending machine so that I can buy more time?
Yeah, we all need more time.
Yeah, very quick question. You kind of mentioned something about an NFT that behaves over time.
Yeah.
You don't interact with it. I actually have a use case for that. What is your use case for that?
Just experimenting, learning, seeing what I can do. Yeah, I think like I don't know, it would sort of like kind of feed activity and encourage people to trade and play with them and do things, but
do something with it, trade it or something, or it goes away.
Yeah, exactly.
How did you come up with the idea for the time?
Well, so like I said, I was kind of exploring on-chain NFTs for what the duck for the next kind of iteration there, and I wanted some sort of something that I could tackle. And clocks are fairly easy to like, it's a circle with a couple hands, so they're easy to draw. And I'm not a super quick or amazing artist, so I went with the clocks. And as far as like on-chain data, block time is very simple to get. There's a built-in function call you can call, and yeah, I'm kind of handy with CSS animations, so it just seemed like a very tackleable project.
It's pretty creative.
Thank you. It was a lot of fun.
So the problem with SVG images are that they can't be really complex. If you want a high quality image, you can't do that with SVGs. So of course the obvious solution would be to encode like a PNG image in base format. But of course the problem is that there's limitations in how much data a smart contract can store. So you might not know this, but like what the constraint is, like how much data can like contract store itself.
So I believe that it's 32 kilobytes is I believe for one contract. But as far as like the get token or get metadata URI or get token URI, the constraint there is really like the amount of gas used. So I kind of asked this on Discord the other day of like what the maximum possible length of a string that I could return. And it depends on, I think, how much like concatenation you're doing. If it's like one very long string, then it could be extremely long. But if you're like doing complex, like generating a very complex image, then the gas usage would be much higher. Yeah, so like the 32 kilobytes isn't an issue in my mind because you could store between multiple contracts and then fetch them. But then, of course, there's more gas implications there. So, yeah.
Actually, this inspired me to have another idea. We could store the hash of data on the blockchain, and then we can upload the files to, for example, 3 different decentralized storage, and then we store the 3 links on the blockchain.
Yeah.
And then we query for the token URL. We return one of the URL randomly on it, and then off-chain we can verify the hash of the data. So this can increase the kind of the resilience of the storage.
Yeah,
it's not on-chain still.
Yeah, that'd be. I mean, yeah, that'd be cool for sure. Very cool. Okay. Well, thank you for your time.